Hello, ladies and gentlemen, fellow math contest enthusiasts. Root Beer here with more of the 2001 Cayley paper that we've been going through for the last little bit. We're up to question number 13, which is a question about two sequences. So we have 3, 20, 37, 54, and 71, and that just keeps going. Let's see, it looks like we have a difference of 17. So this term is going up by 17. The sequence is going up by 17s. And we have another sequence here, 16, 27, 38, 49, 60, 71. This one's going up by 10, no, not 10s, 11s. So this sequence is going up by 17s, this one's going up by 11s. They each have 71 as the common term. Okay, so they each have 71 in common. So 71 is a common term. The next term in these sequences that these sequences have in common is, and we have all these possibilities. Okay. So, I can think of two ways to maybe try and figure this one out. One, we can test each of these to see if they're in the sequences, and we test from lowest up to highest, and then we'll get the smallest one, because one of these 5 answers is the correct answer. So if we can show that 115 is in both of these sequences, then that's got to be it. If it's not in one of the sequences, then it can't be the answer, because it has to be in common. Likewise, if we then figured out that 187 was in both of these sequences, well, 115 was ruled out, so then 187 is the smallest one. Another thing we could do is try and use the fact that this one's going up by 17s, this one's going up by 11s, to actually work out what the next common term is. Okay? So 3, 20, 37. That's going up by 17s. And the other one started out at 16, 27, 38. This goes up by 11s. Okay. So what we could do is we could write the first sequence as 3 plus 17n, and we'd have the 0th term, the first term, the second term, and so on. And the second sequence we could write as, actually, have a first term, second term, and so on. And we could write this one as 16 times 11 m minus 1, and we'd have the first term, second term, third term, and the nth term. And we could say, well, let's let that equal to, I think it was 115. And see, can we solve for n as an integer? And here, can we solve for m as an integer? So that's one way we could do it. But 17 and 11 are prime numbers. Specifically, they're relatively prime to one another. So, let n be the next common term. We'll say n is p terms in the first sequence after 71 in first sequence, and q terms after 7, because this next common term has to be after 71 in the second sequence. Okay. Then n we can write as, well, it's 71, and then we add on a certain number of 17s, p many 17s. But we also know it's going to be 71 plus a certain number of 11s. We'll say q 11s. Well, both of these are equal. So 17p is equal to 11q. So 17 needs to divide 11 times q, and 11 needs to divide 17 times p. But one of the nice properties of prime numbers So if I have, if x is prime, and x divides a times b, then x divides a or x divides b. You could divide both. So we'll just keep that as a little side note. This is a nice property of prime numbers, and 17 and 11 are both primes. So either 17 divides 11, which is not true, or 17 divides q. Okay? So that one definitely can't happen. And similarly, because 11 is prime, similarly 11 divides p. So we're looking for values of p and q that are multiples of 11 and 17 respectively. So why don't we try p is equal to 11? So then n is 71 times plus 17 times 11, which is 71 plus 187, which is 258. And we want that to also be in the other sequence, so it's got to be 71 plus 11q, and q had better be a multiple of 17. Well, it turns out that q pretty quickly, these two are the same, so q has got to be 17. That gives 258 as the next common term. So how do we know there can't be another one smaller? Well, if n is a common term, we've shown that p has to be a multiple of 11. P can't be 0, otherwise we just get 71 back. So the next smallest multiple of 11 we try, and that's 11. And it turns out that gives us 258. So that should be our smallest number. If we had started with q can't be 0, otherwise n will just be 71 plus 11 times 0, so that would just be 71. So we try q as the next smallest multiple of 17. That's 17. And if we plug in 17 into this equation, we get n is equal to 258. So no matter which way we go at it, we get 258 as the next term, the next common term. And I think it was one of the answers. I mean, it better be, otherwise we've made a mistake. There it is, it's C. And actually, if I'm not mistaken, I think 258 was also our answer to the last one. Yeah, cool. So it was the answer to the previous question and to this question. That's kind of nice. You wouldn't expect that. It might give people some pause and think, oh, they can't have possibly done 258 as the answer to both of these. But there it is. So that's the answer to question number 13 on the Cayley. And we're going to be taking a look at question number 14 in the next video.